Students, this is the ALEKS Quiz 3 explanation videos. You want to have this handout right in front of you, and then you want to follow through and take notes. We're going to be working through 5 problems here. So first we're going to talk about similar polygons. Similar are things that have the same shape but a different size, and that's the symbol here. And when things are similar, you have scare going on. Scare means when things are similar, you're going to have congruent angles. So angle C is going to be congruent to angle L. Angle D is going to be congruent to angle M, and the like. And more importantly, RE means the ratios of the sides are going to be equal, which means you can make proportions. Once you establish your proportions, it's all downhill from there. So we want to solve for our unknown, which is x. So the first thing we must do is find our matching side in the same position, and in this case it's going to be BC. So we want to establish our direction. It honestly doesn't matter whether I go 4 over x or whether I go x over 4. What does matter is whatever direction I start, I must finish in that same direction. So I'm going to circle 4 and draw an arrow to x, so I'm establishing my direction as left to right. So I'm going to go 4 over x. Now I find any other 2 sides, and this time I want nothing but numbers. And because I started left to right, I must continue left to right. So I'm going to go 3 over 2.7. From here you cross multiply. And you want to get in the habit of not touching a calculator until x is by itself. So we're going to circle x. Your goal is to get x by itself and then pick up a calculator. Let me show you what I mean. To get x by itself here, you divide by 3, obviously. So now we have x equals 4 times 2.7 divided by 3. X is now by itself. Now you pick up a calculator. So for this calculator, I'm going to go 4 times 2.7 equals, then I'm going to divide by 3, and I get 3.6. Now it's very important you look at the instructions and it asks you where to round to. Since it doesn't tell us to where to round to, we're just going to assume it rounds to the 10th place. So the answer here is 3.6. It says triangles and parallel lines. Now there's 2 ways to look at triangles and parallel lines. When you have a triangle, you want to draw this, and we slice it by a line parallel to one of the sides, so slice by that parallel line. There's 2 ways you can look at this, 2 different perspectives. One would be to view it as 2 similar triangles. So for example, that small green triangle is similar to the larger overlapping red triangle. So one view would be to see that the triangles are similar. Another view would be to view this simply as segments with parallel lines. For example, if we add a parallel line here, we can see these segments. See the pink segments? And the light pink segments. We can see those as proportional. So we can view this as 2 separate triangles or proportional segments of parallel sides. So let's take a look at the information we have here. It's very important when you do these problems that you draw them out. So we are told very slowly that BC and EF are parallel. So BC, trace it, and EF are parallel. Next, we are told that EB is 20. So EB is 20. And we are told that DE is 15. Switch colors. And we are told that FC is 28. And we're trying to find DF. Okay, now you need to visualize these segments here and ask yourself, does it look like the given information would best fit with two separate triangles or pieces of parallel lines? You ask yourself, what is this best fit? And if you look carefully, it's this one best fits the one on the right, which means pieces of parallel lines, because here are parallel lines, and it's all fit on those pieces. So we can make a proportion doing this. We can go this direction if we'd like, top, bottom, 20 over 15 equals 28 over our unknown. Or you can go this way even. We can go straight across, we can go left to right, like this. We could go 20 over 28 equals 15 over unknown. We're going to get the same thing, but the name of the game is consistency. However you start, you must finish. However you start, you must finish. So now we cross multiply, and we're going to get 20 times x equals 15 times 28. And if you look closely, if we did this way, you end up with the same thing. 20 times x equals 15 times 28. Remember, don't touch a calculator until x is by itself. So we're going to divide both sides by 20. And we end up with x equaling 15 times 28 divided by 20. Now you pick up your calculator. 15 times 28 divided by 20. And we get 21. Now what's nice is just check the ratio here. The ratio of 20 to 15, 5 goes in there 4 times, 5 goes in there 3 times. Let's check over here, 28 and 21. 7 goes in here 4 times, 7 goes in here 3 times. Aha! Check. It works. Let's try this one. It says we have QR, again, is parallel to TU, and SQ is 33, and ST is 21, QR is 44, and we're trying to find TU. Okay, remember, when you have a triangle with parallel lines, you have 2 ways to view it. Okay, triangle with parallel lines. Let me just draw a little baby triangle here. You have parallel lines slicing through it. You have 2 ways to view this. Either you can view it as parallel lines with segments going this way, just the segments on the side. or you can view it as two distinct triangles that are similar. You look at your given information and you figure out which perspective best fits the given information. And if we look here, if we were to only use these segments on the side, we would be missing the 44 and the x, so we can't use that one. So this one is not an option. We're going to have to pull these apart and make them two distinct triangles. Let me show you here. We have your smaller triangle. We're going to pull it out. We have 21 and x. And then you have your larger triangle. We're going to pull it out. And in the larger triangle, this whole side is 33, and this whole side is 44. Now you see it's quite easy to solve for x when you pull the triangles apart. So we're going to do our proportions, and again, I'm going to give you two examples, both which will yield the same result. We can go like this. We can go 21 to x, and then go 33 to 44 over 33 to 44. That would be a match. Notice I'm using arrows to keep the direction the same. I'm going to pause and let you write that down. Or you could go this way as well. Again, the name of the game is consistency. However you start, you must finish. We could go this way, or we go 21 to 33. Equals x to 44. And you cross multiply. Either way, you're going to get the same thing. I'm going to use this second one here. We're going to cross multiply. I'm going to bring it over here to show our work. We're going to get 21 times 44 equals 33 times x. Catch up? Alrighty. We solve for x, and remember we don't touch a calculator until x is by itself. So we're going to divide by 33, cancel, get 21 times 44 over 33 equals our x. Now you grab a calculator. We have 21 times 44 divided by 33, and I get 28. So x equals 28. Now just for kicks, you can go back and check to see if this ratio actually works. If I do 21 to 33, 3 goes into 21 7 times, and 3 goes into 33 11 times. If I look here, 28 to 44, I see that 4 goes in here 7 times and 4 goes in here 11 times, so I can see my ratios match. And that's everything we want, is ratios being equal. Using ratios and similar items, we can do what's called indirect measurement. So it says a woman wants to measure the height of a nearby tower. She places a 7-foot pole, in the shadow of the tower so that the shadow of the pole is exactly covered by the shadow of the tower. So the shadows exactly end at the same spot. The total length of the tower's shadow is 179 feet. The pole casts a shadow of 6.75 feet. Our goal is how tall is the tower. First thing you want to do is label everything very carefully. She places a 7-foot pole, so this is 7 feet. And it says right here, the total length of the tower shadow is 179 feet. So from here to here is 179 feet, total length. And the pole casts a shadow which is 6.75 foot. So it's 6.75 feet. And we want to find the height here. Okay, first thing you want to do is you want to pull these apart. So we have the height of the pole, the height of the tower and the shadow of the tower, 179 feet. And we have the height of the pole, which is 7 feet, and the shadow, which is 6.75 feet. Now close this up, we're going to end up with triangles. Pause, I want you to draw that, please. Now the first things to establish is whether or not these things are similar, because if they're not similar, you cannot use ratios, and you have 3 shortcuts for similarity: angle-angle similarity, side-angle-side similarity, or side-side-side similarity. Well, the first one we can eliminate. We don't have 3 pairs of sides, so we're going to cross that out. Let's look at what we do have. In these storylines, anything that's like to the ground, you can assume is a right angle. So we have a right angle, so we do have a pair of angles here that are congruent. And because we have the sun, the angle towards the sun for both created by the shadows is also congruent. So this angle here, they overlap at. So we see immediately these triangles are similar by angle-angle. And because they are similar, we can use a ratio. Now there's a couple ways I can go here. It honestly doesn't matter. I could go this way. X over 7 equals 179 over 6.75. Or I could do x over 79 equals 7 over 6.5. Notice what's important is the direction you start with is the direction you finish. So I'm going to do that first direction. I'm going to go top-bottom. So x over 7 equals top-bottom 179 feet over 6.75 feet. And we cross multiply. So I end up with 6.75 times x equals 179 times 7. We don't get our calculators out till x is by itself, so I divide both sides by 6.75. I end up with x equals 179 times 7 divided by 6.75. So now we get out our calculators, and we're going to do 179 times 7 equals, divided by 6.75 equals, and we get 185.62. Very important in ALEKS that you pay attention to where it wants you to round, or you're going to get frustrated. It says, very carefully, round your answer to the nearest foot. So look carefully. We have 185.6 feet. (185.6), and we want it to the nearest foot, so in this case it's 186 feet. Actually on ALEKS I think it's FT. So make sure you read the instructions about where to round, or you're going to get frustrated because you get the right answer, but you just plug it in at the wrong decimal, and you're going to get frustrated. So make sure you read the instructions. Put your finger on the screen and read the instructions. Okay, we're going to do one more here. Isabel wants to measure the height of the tree. She sights the top of the tree using a mirror that is lying flat on the ground. So we have a mirror here, flat on the ground. The mirror is 32 feet from the tree. So from here to here is the mirror, and it's 32 feet. And Isabel is standing 11.1 feet from the mirror. So here's Isabel standing 11.1 feet from the mirror. Her eyes are 5 feet above the ground. So right here is 5 feet above the ground. How tall is the tree? There's our unknown. Now, again, you should get an inkling that yes, you're going to use proportions, but first you have to establish why these triangles are similar to begin with. Our three shortcuts are angle, angle, side angle, side similarity, and side, side, side similarity. Side, side, side similarity, you must have 3 sets of complete sides, which you don't, so we're going to toss that. Let's look at what you do have. Because of reflexive angles here, reflective angles, angle of incident and angle of reflection, we have a pair of congruent angles. Also, anything in our storyline that is to the ground, we're going to assume is a right angle. So in this scenario, we know they're similar by angle-angle similarity. That allows us to do a proportion. What proportion am I going to use? Well, once again, consistency is the name of the game. I can go left to right. 32 over 11.1 equals x over 5. Left to right, left to right. Or I could do this, top to bottom. If I want x over 32 equals top to bottom 5 over 11.1. Again, it doesn't matter which direction you start with as long as you're consistent in the second direction you use, as long as it mirrors. I'm going to use the top to bottom method this time, so I'm going to have x over 32. So that's height over shadow equals height over the shadow, 11.1. Cross multiply. And isolate x. Once you've isolated x, you want to finish this up. So we're going to isolate x. 5 times 32 divided by 11.1 equals, and we get 14.4. So here we have 14.4, and really critical, let's double check where our rounding. We want to round to the nearest foot. So with that, your answer you plug into ALEKS is going to be 14 feet. Please read the instructions, because if you say 14.4, technically you are correct, but you're not putting in the way ALEKS wants it, and it's going to mark you wrong, you're going to get frustrated, etc. Please read the instructions and follow the instructions.